In this video, we are going to talk about Born-Haber cycle. Actually, the basis of this comes from the Hess's law. The Hess's law says that if we perform a reaction, this Na solid plus half Cl2 gaseous to NaCl in one step, or if we perform this reaction in multiple steps, the total change of enthalpy will be same. So from the Hess's law, the Born-Haber cycle actually constructs. Now look, if we take a metal in solid state, then we have to give the enthalpy of sublimation to make it in gaseous state. Then the enthalpy of ionization makes it in ion, cation. And now if we take a halide, then we have to supply the bond dissociation energy to make it a free gaseous atom. Now this we are using half because it has X2. So if it dissociates, this will give 2X atoms. And we are dealing with only one atom, that's why we are just multiplying half with this. And with this gaseous atom, if we supply the electron affinity enthalpy, then actually this will be negative. That means we don't have to supply this will just produce energy, and this will give the halide anion. Now from this two, if we combine these two, they will give lattice energy. They will just need lattice energy and they will form this MX type of compound. We can directly form this MX from these two, and that will give the enthalpy of formation. So this enthalpy of formation will be equals to all these enthalpies and the summation of lattice energy. So these all will be equal to this according to numerical value. Now I have taken the example of NaCl. Just see if we try to convert the solid sodium and gaseous chlorine to NaCl, we need to give this heat of formation. That means enthalpy of formation. Now, if we try to perform it in multiple steps, then first of all, we have to give the heat of sublimation to this sodium. So we will get sodium gas. Then we have to dissociate the bond between these two chlorine. So this will take half del H dissociation. Now we will provide the ionization enthalpy, then electron affinity enthalpy, and after that the del H lattice, that means lattice energy. So numerically this del HF will be equal to the summation of all these enthalpies. This is the Born-Haber cycle, from which we can calculate the lattice enthalpy of any ionic solid. And even we can, if we know this lattice enthalpy and this formation enthalpy, we can calculate any value of this, any one unknown value. Now this system have some drawback. The calculated values of lattice energy or electron affinity may deviate from the original value. So this is actually the theoretical part, and the actual calculative part, the original value may deviate from this calculation. The lattices are considered to be 100% ionic, which is wrong. Yes, if we consider that all the solids, ionic solids, are 100% ionic, that's not true, because there is some degree of covalency in those ionic solids. So we have to consider that degree of covalency for the appropriate calculation.